Comprehensive report. Breakthrough space mission announcement: NASA and SpaceX's manned mission to Mars and potential alien life discovery. Executive summary. The announcement of a successful manned mission to Mars or the discovery of potential signs of alien life by NASA or SpaceX would mark a pivotal moment in human history. Such a breakthrough, whether through SpaceX's ambitious Starship program or NASA's Artemis to Mars roadmap, could redefine humanity's place in the cosmos. This report explores a hypothetical scenario where NASA and SpaceX jointly announce a successful crewed Mars mission in 2030, coupled with tantalizing evidence of past microbial life. Drawing on recent developments, such as SpaceX's Starship test flights and NASA's Perseverance rover findings, this report examines the scientific, technological, economic, and cultural implications of such an event. It incorporates historical context, current mission plans, and speculative projections to provide a lucrative, engaging analysis for stakeholders, policymakers, and the public. Introduction. The quest to explore Mars and uncover evidence of extraterrestrial life has driven space exploration for decades. NASA's Mars 2020 Perseverance mission and SpaceX's Starship program represent the forefront of this endeavor. A successful manned mission to Mars or the discovery of alien life signs would captivate global attention, with YouTube videos of launches, landings, or scientific revelations potentially garnering tens of millions of views. This report envisions a 2030 announcement where NASA and SpaceX confirm a crewed Mars landing and the detection of fossilized microbial traces in Jezero crater, leveraging data from Perseverance and new human exploration. It analyzes the mission's context, impacts, and opportunities, using historical and recent examples to ground its projections. 2. Background and context. 2.1 Historical context. Mars exploration has evolved from early flybys, Mariner 4, 1965, to rovers like Curiosity and Perseverance, which have confirmed past water presence and organic compounds. NASA's Viking missions, 1976, first searched for life, yielding ambiguous results. More recently, Perseverance's PIXL and SHERLOC instruments have detected organic molecules in Jezero crater, a former lakebed, hinting at past habitability. NASA, 2021. SpaceX, founded by Elon Musk, has pursued Mars colonization as a core goal. Its Starship, the most powerful rocket ever built, is designed for reusable interplanetary travel, capable of carrying 150 metric tons to Mars. Musk's 2024 announcement of uncrewed Starship missions in 2026 and crewed flights by 2028 sets an aggressive timeline. 2.2 Recent developments. NASA's Artemis program. NASA plans to use lunar missions to prepare for Mars exploration by 2035, testing technologies like the Space Launch System, SLS, and Orion spacecraft. Artemis 3, scheduled for 2026, will land astronauts on the Moon's south pole to study water ice, a critical resource for Mars missions. SpaceX's Starship progress. Starship's fourth test flight in June 2024 achieved orbital insertion and partial reusability, with plans for a fifth flight in 2025 attempting a booster catch. Musk's goal is to launch uncrewed missions to Mars in 2026 to test landing reliability. Potential alien life signs. In April 2025, NASA's Mars Reconnaissance Orbiter imaged a 328-foot wide pit, described as a possible portal to underground caves that could harbor microbial life. The USGS identified over 1,000 such cave entrances, prime targets for future exploration. 3. Hypothetical scenario, 2030 announcement. 3.1 Mission overview. In this scenario, NASA and SpaceX announce on January 15, 2030, that a crewed Starship mission, launched in 2028, successfully landed 4 astronauts in Jezero crater. The mission, a public-private partnership, combines NASA's scientific expertise with SpaceX's reusable rocket technology. The astronauts spent 30 days on Mars, collecting samples and confirming fossilized microbial traces in sedimentary rocks, building on Perseverance's findings. Crew and equipment. The crew, including 2 NASA astronauts, a SpaceX engineer, and an international scientist, used a Starship equipped with life support systems, radiation shielding, and rovers. The mission carried advanced versions of PIXL and SHERLOC for in situ analysis. Scientific discovery. The team identified unambiguous biosignatures, fossilized microbial structures, verified by spectrometry and imaging, suggesting Mars hosted life 3.8 billion years ago when it had liquid water and a denser atmosphere. 3.2 Announcement details. The announcement, broadcast live from NASA's Jet Propulsion Laboratory and SpaceX's Starbase, features CGI visuals of the landing, astronaut helmet cam footage, and microscopic images of the biosignatures. The event trends on YouTube, with live streams by NASA, SpaceX, and news outlets like CNN and BBC amassing over 50 million views within 24 hours, rivaling the 2012 Curiosity landing's viral impact. 4. Scientific and technological implications. 4.1 Scientific breakthroughs. Astrobiology. The discovery of fossilized microbes would confirm Mars' past habitability, reshaping our understanding of life's origins. It would validate theories that life emerged independently on Mars or was seeded via panspermia. Geological insights. Human exploration would map Jezero's geology, revealing details about ancient water flows and volcanic activity. Samples returned by a future mission, planned for 2031, would undergo lab analysis, surpassing robotic capabilities. Magnetospheric studies. NASA's ESCAPADE mission, launched in 2025, provides data on Mars' hybrid magnetosphere, aiding radiation protection for future missions. 4.2 Technological advancements. Starship's reusability. The mission demonstrates Starship's ability to land on Mars and return, reducing costs from $1 billion per launch, SLS, to under $200 million. Life support systems. Innovations in closed-loop life support, tested on the Moon via Artemis, sustain astronauts for the 6-7-month journey and 30-day surface stay. In situ resource utilization, ISRU. The crew uses ISRU to produce oxygen from Martian CO2, a technology pioneered by Perseverance's MOXIE experiment, paving the way for sustainable colonies. 5. Socioeconomic and cultural impacts. 5.1 Economic opportunities. Space industry growth. The mission fuels investment in aerospace, with SpaceX's valuation potentially exceeding $500 billion. Contracts for robotics, AI, and habitat construction surge, creating thousands of jobs. Media and content creation. YouTube videos, documentaries, and live streams generate millions in ad revenue. A SpaceX-produced 4K landing video could surpass 100 million views, leveraging the viral appeal of past launches. Tourism and education. Public interest drives demand for space-related tourism, e.g., Blue Origin suborbital flights, and STEM programs, with universities expanding astrobiology departments. 5.2 Cultural impact. Global inspiration. The announcement unites humanity, echoing the Apollo 11 moon landing's cultural impact. Social media platforms like X see billions of posts with hashtags like #MarsMission and #AlienLife. Philosophical shifts. Evidence of alien life sparks debates on religion, ethics, and humanity's role in the cosmos, with thought leaders like Elon Musk and Neil deGrasse Tyson shaping discourse. 5.3 Challenges. Risk to astronauts. The mission's 250 million-mile journey exposes crews to cosmic radiation and psychological stress. Musk's 2018 comment, "Difficult, dangerous, good chance he'll die," underscores the risks. Public skepticism. Misinformation on X could fuel conspiracy theories, requiring NASA to counter with transparent data releases. Cost and equity. Critics question the mission's $10 billion cost, demanding investment in earthly issues like climate change. Ensuring equitable access to space benefits remains a challenge. 6. Historical case studies. 6.1 Apollo 11, 1969. The moon landing, watched by 600 million people, set a precedent for global engagement with space missions. Its YouTube archival footage continues to attract millions, suggesting a Mars mission's viral potential. 6.2 Curiosity rover landing, 2012. Curiosity's 7 Minutes of Terror video garnered 20 million views, demonstrating the public's appetite for dramatic space content. A manned mission with human narratives would amplify this. 6.3 Perseverance's sample collection, 2021. Perseverance's detection of organic molecules in Jezero crater, reported in 2021, sparked global excitement, with news videos hitting 510 million views. A human-confirmed biosignature would dwarf this impact. 7. Preparation and execution. 7.1 NASA's role. Artemis program. Lunar missions test habitats, radiation shielding, and ISRU, critical for Mars. Artemis III's 2026 lunar landing informs Mars surface operations. Scientific planning. NASA's Human Exploration of Mars Science Analysis Group, co-chaired by Joel Levine, prioritizes astrobiology and geology questions, guiding the mission's objectives. Sample return. Perseverance's cached samples, to be retrieved by a 2031 mission, provide a baseline for human exploration. 7.2 SpaceX's role. Starship development. SpaceX's 2026 uncrewed missions test landing precision, with Optimus robots deploying infrastructure. Crew selection. SpaceX trains astronauts for high-risk missions, drawing on Crew Dragon's success in ISS missions. 7.3 Public engagement. Social media. NASA and SpaceX leverage X and YouTube for real-time updates, with live streams of the launch and landing. Posts during Starship's 2024 test flights reach millions, setting a precedent. Educational outreach. Interactive apps and VR experiences simulate the Mars mission, engaging younger audiences. 8. Recovery and future prospects. 8.1 Post-mission recovery. Astronaut health. Crews undergo extensive medical evaluations to study radiation effects and microgravity impacts, informing future missions. Sample analysis. Returned samples are analyzed in Earth labs, potentially confirming biosignatures and guiding exoplanet research. Public narrative. A Netflix documentary series, akin to Apollo 11 Inches, 2019, could gross $50 million, sustaining public interest. 8.2 Long-term vision. Mars colony. SpaceX aims to establish a self-sustaining city by 2050, with Musk projecting 1 million residents within a century. Interplanetary exploration. The mission paves the way for crewed missions to Europa or Enceladus, where subsurface oceans may harbor life. Policy shifts. International treaties, like the Outer Space Treaty, may be revised to address Mars colonization and resource rights. 9. Lucrative opportunities. 9.1 Media and entertainment. YouTube revenue. Live streams and highlight reels could generate $20 million in ad revenue, based on viewership trends for SpaceX launches. Merchandising. Starship models and mission-branded apparel, like the $47.99 Starship die-cast model, see booming sales. Film and gaming. A Hollywood blockbuster or AAA video game about the mission could gross hundreds of millions. 9.2 Commercial space. Launch services. Blue Origin's New Glenn and other providers compete for Mars payloads, driving down costs. Tourism. Suborbital flights gain traction as space becomes accessible, with companies like Virgin Galactic capitalizing on public excitement. 9.3 Scientific investment. Astrobiology funding. Universities and governments allocate billions to study Martian life, spurring innovation in biotech and AI. Private partnerships. Companies like Rocket Lab, which built ESCAPADE's spacecraft, expand into interplanetary markets. Conclusion. A NASA SpaceX announcement of a successful manned Mars mission and potential alien life discovery in 2030 would be a landmark achievement, rivaling the Apollo era. The mission's scientific breakthroughs, from confirming past life to mapping Mars geology, would reshape our understanding of the cosmos. Its economic and cultural impacts, amplified by viral YouTube content and global discourse, would inspire generations. By leveraging NASA's expertise and SpaceX's innovation, humanity would take a bold step toward becoming a multiplanetary species, with profound implications for science, technology, and society. 11. Recommendations. Accelerate Starship testing. SpaceX should prioritize 2026 uncrewed missions to ensure landing reliability. Enhance public engagement. NASA and SpaceX should use X and YouTube for transparent updates, countering misinformation. Invest in ISRU. Scale up MOXIE-like technologies for sustainable Mars habitats. International collaboration. Partner with ESA and JAXA for sample return and future missions. Ethical frameworks. Develop policies for handling alien life discoveries and Mars colonization.